Algebra 2, Concept 6A. So here we're going to be looking at a new function, but you'll probably remember it from Algebra 1. It's a quadratic function, and we're going to look at transformations of these. So get some vocabulary and definitions and formulas down. Remember, if you need to pause the video to finish a definition, be sure to do that. A quadratic function is a function or an equation with a U-shaped graph that we call a parabola. The parent or the most basic form of this function is y equals x squared. Vertex form is one way that this equation, this quadratic equation or function, can be written. And so when it's written in the form f of x or y equals a times x minus h squared plus k, that's vertex form right there. And that is where a, h, and k in the formula are constants or numbers. And then your x and your f of x or your y are just your permanent variables. The vertex of a parabola is the lowest, a minimum, or the highest, a maximum point. And one other thing to add is we can actually find the vertex by picking out the values h, that's the x value of the vertex, and k, that is the y value of the vertex. The last definition, or last two, is transformation. Transformation is just a change in size, shape, or position of the graph, and that's caused by changing of the equation. And in this concept, we're going to look at translations in particular. So this is just what we call a shift of a graph. And so that means it's going left or right, which is horizontally, or up or down, which is vertically. There is no change in shape or orientation. So now let's put this together. Let's look at the equations and graph them and see how the parabola behaves. So the first thing we're going to graph is what we call the parent function, which is either f of x or y equals x squared. So write that just in your first table. And then in a graph, we always want to see what a graph is doing in the negatives, at 0, and in the positive. So I'm just going to pick the most basic values, -2 to +2. And then what we do is we just plug each of those numbers into the equation for x. So -2 squared is 4, -1 squared is 1, and so on. Now on your graph space, you're going to draw an xy axis right in the middle and label it. And then label a scale. And then plot those points. +1, 1, and 2, 4. Now here's where you're going to draw a nice smooth U-shaped curve and place arrowheads at the end of that, because we could just continue going if we plugged in more values for x. So this is our parent function. Now we're going to use that same process to graph this quadratic. It is a quadratic because it's to the second power, so we're going to change that to y equals x minus 2 quantity squared. And the first thing we want to pick out is the vertex. So remember, in our definitions, I let you know that the vertex can be found at the value hk. And so we just compare it to this. H is whatever is being subtracted. So in this case, h is +2. And then there's nothing being added or subtracted at the end, so our k value is 0. So our vertex is the point 2, 0. And then place that in the middle of your table, because that is the middle point. And then we're going to plug in values that are in the negative directions, 2-step, and then in the positive direction. Now, just like in the parent function, you're going to plug in each of these numbers for x. So 1 minus 2 is -1, squared is 1, 3 minus 2 is +1, squared is 1, 4 minus 2, 2 squared is 4. I'm going to graph in red so you can really see, and you graph it on your graph space as well. And we're going to really see the shift. So 2, 0, 3, 1, and then 4, 4. So a nice smooth U-shaped curve. with the arrowheads. Now we're going to describe that transformation. So you can see by looking at the graph that the red graph has shifted 2 to the right. So we're going to call this a horizontal, and I'm going to abbreviate, translation to the right 2. And then we've been asked to identify the vertex, which we did earlier when we started graphing, but we'll just write it here. Our vertex, and in this case, our vertex is a minimum. It is the lowest point. So now you can see how this this equation here relates to the graph. So we're graphing the parent function. Now I've done that already, so you pause the video and do that. Just use the values from the table above from the first example. Then come back and join me to graph the transform function. Okay, so now we're going to graph y equals x plus 2 quantity squared. So let's think about that h and that k value. So it's what's being subtracted here. Well, that would have to be a -2. Another way to think of it is that your h value is always going to be the opposite sign from what you see. Nothing is being added or subtracted at the end. So the vertex of this graph is at -2, 0. Then we'll go 2 in the negative direction, 2 values in the positive direction, and then plug those in. So -4 plus 2 is -2 squared is 4. And then I'm just going to talk you through the rest. -3 plus 2 is -1 squared, and that's 1. -1 plus 2 is 1 squared, which is 1, and this will be 4. All right, I'm going to graph this in red so that we can see our transformation. -3, 1. Nice smooth U-shaped curve. There, now you can see that this has shifted 2 to the left. So to describe our transformation, we'll call this a horizontal translation left 2. And then let's just get down what our vertex, and in this case it's a minimum because it is the lowest point. And so our vertex is at -2, 0. Now we're going to write a general rule for horizontal translations. So on your note sheet, you can just fill in the blank, and we're going to use the evidence that we found from what we just graphed. So if you see, when you look at your equation, an h that's being subtracted, your graph is going to shift to the right. If you see an h that is being added, your graph is going to shift to the left. We call that a horizontal translation. The vertex, again, is going to be at the point HK. Now let's look at some vertical translations. So here we're going to graph the parent function and then the transform function f of x or y equals x squared plus 3. I've already graphed the parent function, so just pause the video and do that using those values from your first example, and then come on back. Okay, now let's graph y equals x squared plus 3. So I've written the general form here so we can pick out h and k easily. Our h value, or what is being added or subtracted to the x, we're looking for parentheses. There is no value in a parentheses grouped with the x, so that means that our h value is 0. Our k value, however, is 3. It's being added at the end of the function. So that's our vertex, 0, 3. Then remember, we're going to step 2 values in the negative direction and 2 in the positive direction. So you can plug these into your calculator or do this math in your head. -2 squared plus 3, and I would advise putting it in your calculator just as I'm writing it, will give you 7. -1 squared, which is 1, plus 3 is 4. 1 squared plus 3 is 4. 2 squared, which is 4, plus 3 is 7. So now I'm going to graph that in red. So negative 2, 7, negative 1, 4, 0, 3, negative 1, or sorry, positive 1, 4, and then 2, 7. Nice smooth U-shaped curve. Every value has shifted up 3, just as this value has been added to our equation. So to describe the transformation, since we're shifting up, it is a vertical translation, up 3. Our vertex is our HK value that we picked out, which is 0, 3, and it just happens to be a minimum. We can go ahead and say that because it is the lowest point in that parabola. All right, one more graph for vertical transformations, and then we're going to write a general rule. All right, ta-da, I have the parent function graphed, so you can pause your video and do that quickly, and then come back. Okay, now let's graph y equals x squared minus 3. So let's pick out our h and k value. Notice there is nothing in a parentheses being added or subtracted to the x value, so that means the h is 0. Here we have a 3 that's being subtracted at the end, so that is our k value, and then these two values make up the vertex, which will be our minimum or our lowest point of our parabola. Then remember, for our x values, we're going to step 2 in the negative direction, 2 in the positive direction, and then just plug them into your equation. So negative 2 squared, 4, minus 3 is 1. Negative 1 squared, which is 1, minus 3 is negative 2. We'll jump down to 1 squared minus 3 is negative 2 again. And I bet you can guess 2 squared, which is 4, minus 3 will be 1. So I'm going to graph in red. So we have negative 2, 1. Negative 1, negative 2. Sorry, let's try that again. Negative 2, 1. And then negative 1, negative 2. 0, negative 3. 1, negative 2. And 1. Alright, so I'm just going to ignore that little rogue point there. U-shaped curve with arrowheads at the end. And then notice that we have shifted down 1, 2, 3 units. So let's describe that transformation. It is a vertical, I'm going to abbreviate, translation down 3. Our vertex was at, or is at, 0, negative 3. And we'll just add that this happens to be a minimum. So now we're ready to write a general rule for how an equation, we can tell from an equation how our graph of our parabola will shift from the parent. So in a quadratic equation, thinking about this general form here, if you see a k value that is being added, so a plus, and that will be a value that's at the end of the equation, then the graph shifts up. And if you see a k value that's being subtracted, and I write little cursive k's, then the graph will shift down. And as always, our vertex is at the point hk. Now go to the independent practice, pause the video, and graph that. Alright, welcome back to check your independent practice. So you should have identified that the graph will be shifting to the left 3, that's a horizontal translation, a vertical translation down 2 because of the values of h, which is negative 3, and k, which is negative 2, and then that determines your vertex, which is negative 3, negative 2. Then you plug in your values, 2 in the negative direction and 2 in the positive direction, and then you should have a graph that is shifting, if you remember from the parent, So to the left 3 and then down 2. And then let's just make a note that that vertex is a minimum. All right, this concludes the notes on this concept. So you can do your Math Excel practice now. Or you may just be moving on to notes. So just consult your plan to see where you'll go next.